You're being recorded now. And f of x is equal to 3x cubed minus 7x squared plus 12x minus 28. So I just want to, let's go through the whole process here of trying to find rational zeros. So first off, what's the most rational zeros I can have? Right, we're all good.
2 turning points. Sorry.
2 turning points. 2 turning points, 3 rational zeros. Scared me there for a minute. All right. All right. So we can have the most 3. So maximum 3. So let's mind our p's and q's. So our p's and our q's. What are our possible p's?
4 and 7. Just kidding. Yeah. Like,
Yeah. No. Just
maybe that's what you want.
pardon me?
No, P was in the front.
No. P is at the back. Q is in the front. Don't ask me why. It would make more sense if P was in the front and Q was in the back from an alphabetical standpoint, but it's not.
2 and 14. Yeah. 1 and 28. Plus or minus all.
Yeah, plus or minus all of those.
Is there any more?
Are there any others? 3 doesn't do it. 4 we already counted. 5 doesn't do it. 6 doesn't do it. And then we're at 7. You know, so and then when you go 7 and higher, you know, you're just reversing anyway, so it doesn't make any difference. Do you know what I'm talking about?
Yeah.
Okay, so I do it in my head. I say, okay, 1 and 28, that's good. 2 and 14, that's good. 3, it doesn't work. 4 and 7, that works, right? 5 doesn't work. 6 doesn't work. And now I get back to 7. Well, 7 is with 4. I already did that one. So it's kind of like I'm climbing up the hill, and I get to the largest factor, and then I kind of start going back down the other side. It's like 4 and 7. Well, I already have 7 and 4. I don't need to write it again.
Yeah.
I go 8, 9, 10. I go all the way to 14. Make sense?
Yeah.
Okay. So you can kind of stop when your numbers start reversing. And our Q, how many factors of Q?
3 was.
Okay. You can. The reason I don't is because when I'm kind of going through them, I like to cross them off. So actually, you know what a good way to do this would be to just kind of write it above it. I'll show you why. So minus 2, minus 14, minus 1, minus 28, and then here I'd have minus 1, minus 3. Right? So those are all my possible factors of P and Q. But now I need to add some here. What are some other ones that I need to add now?
4 over 3.
So 4 over 3, 4 over 3, 7 over 3, 2 over 3, 28 thirds. 14 thirds.
Wait, what are you doing?
Okay. I know that my rational zeros are going to be some combination of P over Q.
So you just put all the values of P over Q?
Every possible one.
Over 3, like,
Right. Not over 1 is not necessary because I already have them listed here.
yeah.
But over 3, yes. Yeah, primarily because 3 is a prime number and it's not a factor over here. Right? If my P, this negative 28 here, let's say it had been 18. So one of the factors would have been 3 and 6. Well, I would have really already covered that because I would have already had 2. Make sense?
Yeah.
Okay. Right. So but I'm listing out my real zero, rational real zero, is going to be some combination. It's going to come from this set, that and that. It can't be any number other than those if it's a rational zero. Are we good with that? Yes.
Um,
Did I miss one?
yeah, 1/3.
1 over 3. Sure, why not? 1 over 3. Did I miss any others? No? Okay, then let's graph it. So I have, let's go y equals, and we'll clear that one out.
But you don't do negative numbers for this one?
Pardon?
You do negative numbers for this one?
Yes. Yes.
Pretend.
Yes. Yeah, pretend that they're both negative and positive. Every one is going to be a negative and a positive possibility. So I have 3x caret 3 minus 7x squared plus 12x minus 28. And I got an extra x in there, so I'm going to stop it before I cause a problem. And we'll delete that. Okay, so I'll zoom 6. Well, that's interesting. It looks to me like it only crosses once. Is that possible? Why? Maximum of 3, right? So of all our rational zero possibilities, what is the one that looks like it might be that? Can you see that clearly enough? Do I need to? What is the one that you think? First of all, we know it's a positive number, right? Because it's on that side of the axis. We've eliminated all of our negative possibilities. What do you think it might be? 7/3. So let's find out. Let's go quit, and we're going to go Alt F4, and we're going to do it for 7 divided by 3. 0. Not bad. Not bad. That's pretty quick. All right. So once I've done that, I want to do this. I want to be able to write this function in a new way. I want to be able to write it so it's depressed. Depressed. They can't see that on the recorder. All right. So, so how am I going to do that? How am I going to write this so that it's depressed? Synthetic division. So I'm going to have, let's use the color here. I'll have 3. I'll have negative 7. I'll have positive 12. And I'll have negative 28. And I'm going to divide that by 7/3. So, a little more room here. I have, bring down my 3, and that's going to be a positive 7, right? 7/3 times 3 is going to be a positive 7. So I add those together, I have 0. That makes that easy to divide. That's a 0. This becomes a 12. And 7/3 times 12, if I would divide the 3 into 12, I have 4, multiply the 4 times the 7, that gives me 28, 0. So it is in fact a 0. And now I have a new equation. I have x minus 7/3 times 3x squared plus 0x, I'll just stick that in there for a minute, plus 12. Is there a question on this? We're okay with how I just did this? Yeah. Okay, so let's make it just a little bit more simple, and then you'll see some more magic. I'm going to go, well, let's do it 2 ways here. Okay, I'm going to go x minus 7/3, that's one of my factors, and I'm going to get rid of my 0x because it's annoying. 3x squared plus 12. But I'm going to factor out a 3 from here, right? I can do that just to make it look a little bit nicer. So I'm going to go 3 times x minus 7/3, and then I'll have x squared plus 4. Now, if I had any doubt whatsoever whether or not this function actually crossed the x-axis someplace other than we can see, you know, like either way over here or way over there, right? How have I now completely erased that doubt? Let's go to the magic bullet probability and press somebody's brain here for me. Brittany, would you answer? Hunter, how have I erased the doubt that it's not crossing the x-axis again? No? Okay, so I have 1, 0 here, right? And that's a 0. I set this to 0, and it's going to make my whole equation 0, right? Well, what happens if I set this to 0? I want to set this to 0. What happens? That's exactly right. Well, it's not an irrational number. It's not a real number, right? X squared plus 4 equals 0. X squared equals -4. I have to take the square root of both sides, and I would end up with an I. I'd end up with a number that is not on the real number line, right? So we've gone from moderately ugly polynomial to relatively pretty fully factored form. Right? Yes, please.
So you took out a 3, but isn't it this? Did you do anything to x minus 7/3?
No.
You're just going to add it to it?
Well, so I have a factor of
I know how you got it on that side.
right.
But I don't know how you got it on the other side, because there is no 3.
Okay, so let's do it this way here. I'm going to change this to x minus 7/3 times 3 times x squared plus 4. So I just took the 3 out of here, and I left it right next to it, right? But you know, with multiplication, it doesn't really matter where we put it, right? So if I have
So it wouldn't affect it.
not if they're all being multiplied times one another. It makes no difference. Right, so if I have 7 times 2 times 5, is that the same thing as 5?
So you're not just, I don't know.
You're asking, am I distributing the 3?
To both equations, or
I only have the 3 one time. So if I was going to distribute the 3, I would only be distributing it, if I could distribute it to this one over here, or I could distribute it to this one over here. I couldn't distribute it to both of them.
Oh.
No. I would only distribute it if I wanted it to the one that it was touching. Right? But so you see, I just moved the order around, and it's nicer to have your constant in the front. All right. Everybody okay with this problem? Yeah? Okay.